Hi, so welcome to another video. So today I'm going to talk to you about different compounds. So in particular, naming ionic and covalent compounds. So covalent compounds are where you have two atoms that come together and they have an overlap of their orbitals and they share electrons. So for this to happen, you usually have two non-metals coming together and sharing those electrons to make that covalent bond. So they're named quite differently to ionic compounds. Ionic compounds is when you have a metal and a non-metal, and they will lose or gain electrons to pick up a charge. So the metals tend to lose electrons to become positive, and the non-metals will gain those electrons to become negative. And we have an electrostatic interaction with those sitting next to each other, and we have an ionic lattice that's formed. So we're going to name these ionic compounds. There's two different main categories of ionic compounds. We have the metals that have one valency and only ever one valency. So these are metals that only have one charge. So potassium, sodium, magnesium always have one charge. The other group of ionic compounds is the multivalent ionic compounds, and these are the metals that can have different valencies depending on the environment or what they're bound to. So, for example, copper, iron, they could have 2+, they could have 1+. There's a lot of variation in a lot of the transition metals in particular. So first of all, let's start with our very basic ionic compound nomenclature, and then we'll go into the multivalent ionic compounds, and lastly, we'll go into the covalent compounds. So KBr, so K is potassium. Potassium always has a 1+ charge on it. Bromide or bromine is the non-metal, and it's always got a negative on it. So KBr comes together, the 1+, the 1-, and they will have that electrostatic interaction. So when we're naming this, we literally just need to work out what that metal is and write it down. So straight off your periodic table, if you've got that available to you. And bromine is bromide. So although it comes up as bromine on your periodic table, you need to add the suffix, so the ending IDE instead of the INE as you have in the periodic table. And so that will be what's on all of the anions. So the anions are the negatively charged part of the ionic compound. Will all have "ide" at the end. So sodium, NaCl. So let's do sodium chloride. That's a classical ionic compound. So then it's just sodium and chloride. So keeping that "ide" in there, looking those up off the periodic table. So another one, so that's just your general ionic compounds where you have your metal that only ever has the one charge. Now if we have a multivalent electron, so a multivalent atom, so let's do this one. So copper is a multivalent atom. It can have different valence charges. Let's do copper sulfate, so CuSO4. So sulfate is a polyatomic anion. It's got more than one atom that makes up that particular compound, and it has a negative charge on it. It may have one, it may have two, it may have more than that. So you need to know about what sort of charge your polyatomic species have. So SO4 is a 2- charge. So if we pull this apart, we know that SO4 is a 2-. So looking that up, you know it's a 2-. The copper, therefore, because this was neutral overall, the positives and the negatives need to cancel out. We've only got one of those coppers, so that needs to account for the same charge as the anion has. So it'd be copper 2 sulfate. So when I write that out, I've got copper, and then I need 2 in Roman numerals in brackets, and then I write sulfate. So copper 2 sulfate. Now let's look at another one. So we might have iron let's do this one, Fe2O3. So this is just a monoatomic, so one atom anion, and this is oxide. And it has a charge of 2- that sits on it. So because this has a 2- on it, and I've got 3 of those, so all up I have -6. So 3 lots of -2 gives me -6. So my Fe needs to be +6. I've got 2 Fe's, so if I've got 2 and it needs to get to +6, that means each ion will be a 3+. This will be Fe3+. Okay, so Iron3 oxide. Now, these are fairly simple examples. So you've got your metals that only ever have the one charge. You don't need to use Roman numerals for them. You just literally write down the name. And then you've got the ones that are multivalent. So you need to work out what is that charge. So knowing the charge on the anion and back calculating to work out the cation. Now these are mostly with monoatomic species for the anion, but we had the polyatomic anion. Now let's try going the other way. Let's go from the name now into the formula. We've got potassium and we've got bromide. So let's go into the formula now. So potassium, if you look that up, you know it's a K+, and bromine is a Br-. So we've got K+, Br-. Those charges cancel out, so it's Kbr. So in the final formula, we're not writing the charges. We're writing the neutral formula for that one. So for sodium chloride, Na+, Cl-, putting it together, they both cancel out, NaCl. Now with copper 2 sulfate, it's a lot easier going this way. So we know copper is a 2+. I don't even need to look that up if I don't know it. It tells me. Sulfate you might need to look up. SO4 2-. So then putting these together now, CuSO4. Again, iron 3+, oxide 2-. Now these ones are a little bit trickier. You need to make sure that the charges cancel out. So an easy way to do that is to swap and drop the charges. So if I've got a +3 here, if I swap and drop that charge, I got a -2, swap and drop that charge, I get Fe2O3. Why do I swap and drop? Where does this swap and drop come from? Is that what you're thinking? Well, let's have a look at it. So if I've got Fe3+ and O2-, I need to get a number that's the lowest possible number between these two so that the pluses and minuses cancel out. So cross multiplying is the way to go. So if I've got 3, okay, I can have 2 of those. So that would give me 6+ if I had 2 times. So then if I had 2 times of this, that would give me 4-. It's not good enough. I need to get to 6. So if I do 3 times, that gives me 6-. So you'll notice that I'm multiplying by the other number to get to that common number between them. So it's a cross multiplication. So it would be Fe2O3. So it doesn't matter which way you get there as long as you're getting to the right answer. And sometimes people are drawn to this and sometimes people are drawn to the quick little maths on the side. There's not that many combinations for, you've always got, there's only a few different ways. There are always +2s, +3s. There's not much variation in there. So that is your basic ones. Now, the only case I haven't discussed is when you have a polyatomic cation or anion and you're going to have multiple ones of those. How do we write that out? So let's say that I have iron, let's go from the name, iron sulfate. Okay, iron sulfate. So I know iron is Fe, and I know sulfate is SO4 2-. Okay. Now, how do I put these together? I need to know more information. Let's make this Iron3 sulfate. Okay, so I know that's 3+ now. Now I can do something. So I've got iron 3+, SO4 2-, and I want to put those two together. So I want to swap and drop, swap and drop, swap and drop. So I get Fe2, SO4, and I'm going to get a 3. So did you notice that I put brackets around the SO4? That's super important. That SO4 is an ionic anion. It's an ion. It is a covalently bound compound that has an overall charge. It needs to stay together as a compound. So I need to put brackets around it and then multiply that out by however many of those that I have in the particular compound. All right, so hopefully that gives you a crash course on the ionic. So let's do the covalent now. So covalent ones are very easy. We literally just write down what we see. I find students think they're so easy they don't practice them. But you need to think about practicing these two. So CO2, how do we write that name? Periodic table, what's this element? Carbon. What's this one? Oxygen. Look them up on your periodic table. Then you use di and tri and mono to say how many of everything. Now with your first element, you don't need to say mono on that one if there's only one, which there is in our case. But on the second element, you would need to say mono if there's only one. We've got 2, so to be carbon, di, oxygen. Now, I need to put "ide" at the end. So ox, ide. Carbon dioxide. So with all nomenclature, "ide" at the end. So let's do CO. So again, I've got carbon at the beginning. I've got 1 at the end, so it's monoxide. What about NH3? So that's nitrogen. Trihydride. So I've got the "ide" at the end. I've got 3 of them. I've only got 1 nitrogen. So let's have a go at another one. Let's do PCl4. So we've got phosphorus. No. Yes. What are these? Look them up on your periodic table. So we've got phosphorus, chloride. What's 4? Mono, di, tri, tetra. So we've got phosphorus, tetrachloride. Okay, so that's how we do our covalent compounds. So thank you for watching the video, and I look forward to seeing you next time.